My name's Steve. I've seen and met some of you before. Thanks for coming to listen to me again. If you want to get a hold of me, you can reach me on Twitter. I'm at ppopowitz. That's P-E-P-O-P-O-W-I-T-Z.
Yeah, how do you pronounce it again?
Ppopowitz. It's a stupid name.
At least you admit it.
Sure. The name Steve Hicks is pretty common. And I didn't want to be Steve Hicks 137. So I've tried to think of the most obscure name that I could think of. And it turns out that it is a character in an animated series from years ago called Home Movies that makes an appearance for about 30 seconds. And that's what came to mind. It turns out nobody has that name anywhere except me. Email is up there also, steven.j.hicks@gmail.com. And all the slides we're going to go through are at the URL. That URL will be in the footer for the whole talk if you decide halfway through that you want it. I want to say thank you to CodeMash and the organizers for having me, for putting it together. All of the sponsors, if you haven't gotten a chance to get out there and thank them at their booths, please do so. They're kind of the reason that these events happen. I help out with a conference in Milwaukee. That's where I'm from. I help out with a conference in Milwaukee, and I will say that there's like two places that you get money for your conference, from the people and their companies that send them, and then from the sponsors, and that's pretty much it. So they're a huge help to a conference like this happening. And then thanks to all of you for not getting super drunk in the hot tub last night and still being up partying like some other people that I saw. Not joking. So like I said, I live in Milwaukee. I work for a company in New York named Artsy. And Artsy's mission is to expand the art market. We're doing that with a platform for collecting artwork and discovering artwork. I'm happy to talk to you about that. Stuck. It's pretty vague. So I want to be really clear about what I mean when I say stuck. Stuck is when you've been looking at code for minutes or hours or days, and you are stuck, and you cannot figure out why it's not working. You're banging your head against it. It feels like you've done everything you should. It feels like it should be working, but it's not. Or it feels like it shouldn't be doing something, but it is. And you're getting frustrated. My favorite thing in development is the act of getting unstuck, or helping someone else get unstuck. If I'm in a stand-up and I hear somebody say, I'm stuck, or give the indication that they're stuck, I get really excited. This is my time. And I'll offer to pair with them or talk to them or whatever it is that they need. I'm happy to get them moving forward. Now, over the past few months, I have collected a whole bunch of tips that I've noticed about myself, things that I do when I'm stuck to get myself unstuck, and some things that my coworkers do too. And I just want to share those with you. My first strategy is only kind of a strategy. It's more of a mindset shift. Let's embrace the stuck. Really quick survey in the room. Can you raise your hand if you consider yourself to be a junior developer or someone newer to development? Okay, so we have, I'd guess maybe 30 people in the room that have their hand up. How about mid-level? Where do you see yourself? Pretty similar. And then what about senior level? I think there's probably a few more seniors in here than there are juniors or mids. Question number 2, can you think of a time in the last 2 months where you were absolutely stuck on code and you couldn't figure out how to get past it? Please raise your hand if you can. Hold your hands up. Keep them up. Juniors in the room, look around and notice that the whole room pretty much has their hands up right now. So any juniors, you can put them down. Any juniors in the room who think that with time you're not going to get stuck, that it's not a reality. It happens to all of us. My coworker and friend, Will, wrote an article on Medium that he called "To Start Meditating, Stop Trying to Empty Your Mind." And Will writes about meditation and how many beginners to meditation get frustrated because they think that they're not good at it. They think every time I sit down to meditate, my mind just wanders and I have all of these thoughts and it goes all over the place. And I'm just not good at it because I can't keep my brain from thinking. Will makes the point in his article that having an empty mind is not what meditation is about, especially for a beginner. It's about being mindful and noticing that you're having those thoughts and letting those thoughts go. He says, it may feel frustrating and like you're doing it wrong, but that is the practice. Similarly, when it comes to getting stuck in your code, it's not a reflection of your skill level. As you saw earlier, everyone had their hands up, even the seniors. It is not an impediment that's preventing you from doing your job. Getting stuck is the job. This is what we are getting paid to do. We get stuck and then we get unstuck. This is our unique skill, and it's why we get paid to do this job instead of someone else getting paid to do it. And in fact, our job is not to write code, it's to solve problems. So it's okay to be stuck because that's just you doing your job. And solving problems takes time. So it's okay if it takes you a while, if you feel like you're stuck for a little bit. With that, I have some more actionable strategies. I have them grouped into a few different categories. Strategy group number 1 is about explaining the problem. It's pretty simple. Start by writing a message describing what's going on in your code to someone else. This could be an email to a coworker. It could be a Slack message, whatever your preferred form of communication is with your coworker. It could also be a Stack Overflow question. Start writing up a Stack Overflow question. Start writing a blog post if you're a person that blogs. Talk about what you think should be happening and why it's not, or how it's not. Start filing a GitHub issue. My preferred method for this is to write a message to Slackbot. Because the truth is, 90% of the time when I start doing this, I don't even need to send the message. By the time I get done with it, I've figured out what my problem is. Similarly, we can talk to the duck. Some people call this rubber duck programming or rubber ducking. But talking to the duck, as far as I could tell, comes from a story in a book called The Pragmatic Programmer. I'm not sure. That's what the internet told me. But it doesn't have to be a duck. It just has to be a thing that you set next to your desk or on your desk. And when you get stuck on something, you pick up that duck or that transformer or whatever the little thing is, and you start explaining, okay, so here I'm doing this thing, and I'm sending this value into the function here. You explain all the details of the code, and you walk the duck through as if they were a real live person. Now, it doesn't actually even have to be a duck. It doesn't have to be anything. It can be imaginary. You can sit there and talk to yourself. But the important thing is that you verbalize it, and you say it out loud, and you make sure that it's clear what you're explaining and what you're telling them. The duck can even be a real thing, like a person. You can talk to a person. One of your coworkers, pull them over to your desk and say, this is what's going on. I just want to talk at you right now. I want to explain this to you. And again, walk them through the code. Explain to them the problem and what is or isn't happening. And you can take this a step further and ask them to sit down next to you and pair with them and pass the keyboard back and forth as you try to make changes and see what's happening, see why it's not working. We pair a ton at Artsy, not all day, but on any given day, I'm probably pairing 2 hours. The interesting thing about pairing, oh yes?
Just
So the question is, should the stuck person be the driver or the one who talks? Initially, the stuck person should be the driver. But if it takes a while, you're going to want to switch back and forth. So yes, so we pair a ton. And the cool thing about pairing is even if you do it when you're not stuck, that's almost more useful than when you are stuck because it helps you not get to that place of being stuck. All of these explain strategies work for a couple reasons. I think that they can partly be explained by something in psychology called the protege effect. And if you've ever taught something to someone, whether it be through just sitting down with them and teaching them something, or teaching a group of interns or new hires at your company, you've experienced this. The protege effect is that the best way to learn something is to teach it to someone else. And there's a couple things that happen when you're teaching something to someone. First of all, you're inspired to learn the topic thoroughly because you have to explain it to someone else and you don't want to look like a fool. So you actually just use better learning strategies. It also has kind of a meta effect where it forces you to think about how other people might best learn it. And so you kind of reshape it in your own head so that you can explain it clearly to them. This is called metacognitive processing, thinking about how you would learn something. There have been a few studies about the protege effect. One of them in 2016, I'm quoting here. The title of the study is really long. I'm not going to read it. But what this study did was arrange students into two groups. There was one group that was told, you're going to go learn this concept just for the sake of learning. And the second group was told, you're going to learn this concept, but when you're done, you're going to teach another student about it. And what the researchers found was that the students in the learning by preparing to teach intervention developed a more detailed and better organized concept map of the problem. What I think is really neat about this study is they were preparing to teach. They didn't actually teach. None of them actually had to go teach another student when they were done. They just went into it with the mindset of, I'm going to be teaching this. And that was enough to prompt them to use better learning strategies. Another thing that is happening when we explain things is that it's forcing us to challenge assumptions. You have to prove that the code that you think is running is actually running. And this made me think about a few things. For starters, there's a book by a psychologist named Mihai Csikszentmihalyi. He wrote a book about creativity. And if you're not familiar with him, you're definitely familiar with his work. Because he talks a lot about the flow state and that feeling of working on a problem that's exactly the right difficulty for you, where you can sit down, start working, feel really productive, and then 8 hours later your day is over and you didn't even realize it. But the book in general is about creativity. And this quote I actually just pulled completely out of context. But it really talks about challenging assumptions. He says, experience this one thing for what it is, not what you think it is. And this made me think a little bit about something that I remember learning when I was a student in elementary school and high school and college in art classes. I had a teacher at one point tell me, literally, draw what you see, not what you think you see. There's a little bit of history behind this. In the 40s, a professor of art education named Victor Lowenfeld talked about 6 different stages that you go through as a young artist. You start out scribbling, then you work through all these different stages, and eventually you're at a period of existential crisis trying to figure out what you're going to do with your life. I've not gotten that far. That's just what I'm told. But for me, where I got stuck is here in the middle. The schematic and dawning realism stages. And this is a stage, or this is a time when a young artist, or old artist like myself, transitions from drawing schemas, which are symbols, to drawing realism, which is what it looks like, what it actually looks like. Schemas, like I said, are just symbols. They're kind of visual heuristics. When we see this drawing, we all instantly recognize it as an eye. It's got that eye shape, human eye shape, and it's got an iris, and it has a pupil. And that's all we need to know that this is an eye. If we were to go ask some of the kids at CodeMash to draw an eye, that's probably what it would look like. It might happen for a lot of the adults. I don't know. But when you transition from this schematic to the realism stage as an artist, what you start to realize is that is not what an eye actually looks like. You start to realize that there's a whole lot of detail and nuance to an eye, to the human eye. There's eyelashes, and sometimes you can see the reflection of the eyelashes in the eyeball. There's the weird little bloody red thing in the corner of the eye that probably has a name. And look at the iris. Those are blue eyes. But there's so many colors in that eye other than blue. There's green, and there's brown, and there's grays. It's not a symbol. It has incredible detail and subtlety. And when you're focused on a problem in your code, you're using symbols to think about your subsystem or your system. If you think about the code that you're working on as basically a combination of 4 different things that you need to work together, maybe one is a database, and one is some settings from the user, and one of them is some business logic. You're just trying to get these 4 pieces to play nicely together. And when you do this, you're making assumptions. These things become black boxes or symbols or schemas. Each one of those different pieces, you abstract it into something. And you say, oh, that's just my business logic. It just works fine. You make assumptions about each one of those pieces. But when you start to dig into it a little bit, you realize that there's a lot of detail and there's a lot of subtlety in each one of those different components. We do have to treat them as black boxes, though, because if we didn't, we would be completely overwhelmed by the complexity that's there. And we wouldn't be able to wrap our head around the problem. Unfortunately, sometimes those black boxes, they don't work like we expected them to work. The assumptions that we hold about them turn out to not be true. And explaining the problem to someone else forces you to look at every one of those components in detail. And that's when you find out, oh, that's what I was doing wrong. Strategy group number 2 is about isolation of a problem. It starts with some risk analysis. Go ahead and ask yourself some questions when you're stuck. For starters, what is the thing that I've introduced that I know the least about? It could be a dependency. It could be some new code that you wrote or that one of your coworkers wrote. What is the thing most likely for me to improperly use? That could be a dependency or some existing code, something that you just haven't looked at in a long time. And what is the thing that I'm making the most assumptions about? If you can give a solid answer to any one of those questions, there's a good chance that that is the reason that you are stuck. That's the source of your stuck. Whether you can or can't answer those questions, we can start removing some code to isolate the problem. A couple ways to do this. One of them is to delete code, just flat out remove it. If you think of your code as just a bunch of blocks of logic, and you aren't sure where the problem is, maybe just go and replace half the code with one single line that does a hard-coded thing that would be the correct answer. Sometimes you can delete lines entirely, but often you have to replace them with a much simpler version. You've removed complexity, though, and if you keep iterating down the line, You can get to a point where, while you were dealing with 50 lines of code originally that were troublesome, now you're down to 10, and it's a little bit easier to figure out what's actually going wrong. If you're using Git for source control, and probably other ones too, but it's a lot easier with Git, you can start backing out your changes to the last known good state. So if you think of the history of your project, you've got commits. And if it worked before but it doesn't work now, just keep rolling them back. Check out the previous commit, and then the previous one before that until you get to the point that things are working. And that can help you isolate the change set that broke your code. This strategy is automated if you use Git. There is a git bisect function that will do this for you. You tell it the last known good commit and the first known bad commit, and it'll go ahead and it'll check out commits in between and use a binary search to try to target the exact commit that broke things. And you just tell it along the way, this one's good, this one's bad. It's really important if you are going to use this strategy that you use small commits. You don't have to push them. You can just leave them on your computer as you're working. And at the end, if you want to squash them when you're done, that's fine too. But committing frequently allows you to roll back smaller pieces. If you think of your system as this super sweet Lego camper, it is pretty awesome. And something in it isn't working right. Maybe you put the wrong size piece in somewhere and you just can't figure out where. The strategy of code removal and backing out changes is a little bit like this. It's like taking your Lego camper apart and trying to figure out, is it the raft that is the problem? Is it the sleeper area, whatever you call that? That's the problem. Is it the base that's the problem? So you just pull these pieces off, trying to find the wrong piece. But sometimes when you get stuck, you're not even sure that you can build the camper. You have bigger questions that are preventing you from even starting. And in these times, it can be useful to just take the pieces that you're worried about. Maybe I'm worried about the platform integrating with the windshield, integrating with the raft, and a wheel. That is a wheel on the bottom. In some cases, it can be easier to go ahead and isolate by building a proof of concept. There's a lot of different ways to build a proof of concept. Basically, what you want to do is get yourself an environment where you can play around quickly without having to focus on setup and starting the project. So some quick ideas. If you're a JavaScript developer, if you just type node into a console, you'll actually get an interactive JavaScript environment where you can write JavaScript. There is a tool that you can use in your code editor named Quokka. And Quokka is a pretty cool thing where you just point it at a JavaScript file, and it'll run it visually for you right there, so you can see what the values are when you console log them. There's a lot of internet-based options, like JS Fiddle has been around for a while. CodePen. It seems like people use CodePen for front-endy stuff, CSS and design problems, but you can also do whatever JavaScript things you need to there. React developers, the new hotness is Code Sandbox. It spins up a React environment for you, a React app for you, in your browser. Glitch is another one that's new and hot, and that is pretty much just JavaScript based, but you can do both client-side and server-side. If you're a .NET developer, there are similar options on the internet, like C#Pad and .NET Fiddle. I wanted to put in some Ruby and Rails ideas, but I only started using Ruby and Rails 3 months ago, so I mostly had to ask my coworkers for help on this one. . But if you do IRB, that gets you an interactive Ruby console. Rails console gets you a console in the context of your Rails app, and you can just poke around in there. Bundle console is a Ruby console in the context of all your gems that are in your bundle. Any other languages, there is a neat tool called REPL-IT, where you can spin up a prototype in a lot of different languages. The only one that I noticed was not in there that I thought would be useful is Elm, because that's something I wanted to play around with. But pretty much anything else that I would want to build something with seems to be on REPL-IT. So we're in this time where we don't really know how to start, and we started prototyping. And sometimes even then we get stuck and think, I just can't do it. It's too complicated. There's too many pieces, and I don't know how they're all going to work together. And I don't even know where to start. You get a little bit of analysis paralysis. And in those cases, I recommend eating the frog. Eating the frog is an expression that comes from Mark Twain. Or that's what the internet tells me. Maybe it was Abraham Lincoln. I don't know. He says, eat a live frog first thing in the morning, and nothing worse will happen to you the rest of the day. It's true. What I take it to mean, and what a lot of people take it to mean now, is basically just do the hard thing in the morning. Do the hardest thing first. So if we're faced with building a system of these 4 pieces that are going to interact with each other, and we don't know how to start because one of them is Mongo, and I've never worked with Mongo, and I just don't know what to do. Take a deeper look at each of them. And what you might find is that 3 of them look really, really simple. And you'll be able to knock those out of the park. But really, there's just one piece that has these crazy details that you're unsure of. And that's where you should start, the one that you're most scared of. You can throw away the code afterwards. You don't have to keep it. But it'll give you an idea of where the code is headed. If the hardest problem seems like it's still too big, again, dig in a little bit deeper. You might be able to identify smaller problems inside of it and find that 2 of them are not so bad, and one specific thing is really, really scary. This is not an advanced tactic by any means. But if you think of your code as a tree of function calls, somewhere along the way, one of those functions isn't getting what it needs. And it can be helpful to just log the inputs all the way down, and then look at them and see who didn't get what they were supposed to get. And then you can pinpoint the problematic function. I get very preachy about writing tests. I think it's one of the most useful skills for a developer to have. It's the best way that I know of to tighten your development feedback loop. If you think of that feedback loop that you're experiencing every day, where you're typing things and you're saving the file, and then you're looking, observing to see what happened, and adjusting based on that, and then you type some more things and observe a change, and then type some more things and observe this loop. We do this all day, every day. And if you're not writing tests, that loop can get really, really loose and big and slow. And it could be as bad as I make these changes, I save them, I commit them, and push them. And then 2 months later, it gets deployed to production, and I can finally go check to see if it works. If you're writing tests, it's in the seconds. That loop shrinks down really nice and tight. So I can make changes to my code, save, and within 2 seconds, I know that I broke something in this other part of the app that I wasn't thinking about. So I have a few ways that automated tests can help you isolate an issue. We can start by writing unit tests of existing functions. Again, thinking about my code as a tree of function calls. Maybe I'm convinced that 5 of those functions are fine, and I'm suspicious about 1 of them, or 2 of them, or 3 of them. I can go ahead and I can target any one of the functions directly with a unit test and just see if, when I think you get these values, what do you do? Are you doing the thing that I'm expecting you to do? And then that can help you verify if that function is problematic or if it's just an innocent bystander. We can write unit tests of new functions. Maybe we have a piece of code here that does some stuff, has some lines, maybe too many lines, but we don't have to talk about that. But looking at it, maybe I can see halfway down there's a piece that looks like it could pull out into its own function. And then I can extract that block and write a unit test against that function directly. And this can, again, help me narrow down whether that block of code is problematic or not. We can also use integration tests and write integration tests for an entire branch of code. Maybe I have a little subsystem here that doesn't seem to be working, and I'll write an integration test that covers the whole thing and find out that it fails. My integration test is covering all those pieces, but it's not working. Since it fails, what I'll do is I'll dive one level deeper. I'll pick one of those branches, one of those sub-branches, and write an integration test of that. And if it fails again, then I know I can keep targeting that branch. And I'll dig one level deeper and write some tests down there. And what I find is, well, one of those sub-branches is green. It's doing what I think it's supposed to be doing. And one of them is red. I'm going to keep digging into that branch. If you have struggled to write tests at any point, and you want to talk more about it, please come find me at some point today, because I'd love to help you get started writing automated tests. The common thread for all these isolation strategies is that it helps you break down problems. You take a problem that's large and turn it into a problem that's small. And problems that have smaller surface area are easier to figure out. Strategy number 3, or strategy group number 3, is my favorite because I don't think any of us do it enough. Escape the problem. Relax. When you're really stuck on something, take a shower or take a nap. I have been told, I work remotely, I've been told that that's a really remote worker suggestion, to just go take a shower in the middle of the day. And maybe that's true. But maybe it's not. When you relax, you shut your brain off from a problem, it starts to wander. Other areas of your brain start to activate, and they can find solutions for you without you even trying. You also get a little more open-minded to the problem, rather than being focused on what you think is the answer. Relaxation is just generally a really great way to be creative. Get some exercise. There's a lot of physical benefits to getting exercise, but there are also mental benefits. It increases the blood flow to your brain. It improves your executive functions and improves your mood, which can be really helpful because I know when I get stuck, my mood goes south pretty fast. If you find a form of exercise that's rhythmic and repetitive, your mind can shut off and start to wander and start to think about other things and solve the problem subconsciously for you. Do something else that you enjoy. This is obviously a very individualized strategy. My coworker Ash mentioned that he likes to play guitar when he's stuck. Maybe you like to draw or knit. I like to exercise. I like to bike. I like to run. I like to climb fake rocks. Whatever it is that is a hobby to you, if you take your mind off the problem, it's going to figure it out on its own maybe. And if all those other ones feel like they're unproductive and a little bit like procrastinating, just move on to a different problem. Find a really, really simple ticket in your backlog, or what you think is a really simple ticket, and tackle that. It feels like a more productive version of escaping. Why does escape work to solve a problem? There's a few reasons. Number one, escaping the problem can boost your confidence, especially in the example where you are going to solve another simpler problem while you put this one on hold. I do this in rock climbing a lot. If you've never been rock climbing before, the TLDR is it's just problem solving. It's physical problem solving. And a lot of times, I'll find a route that I think I can do maybe, but it's really, really hard, and I get stuck at the same spot 5 or 6 times, and I keep falling at the same spot. And I start to lose confidence in myself, in my abilities. And what I'll do is I'll look at the wall and find the 2 simplest routes I can find, and just go climb those. And I can do those no problem. And it gives me that little boost that I need to go back and tackle that original problem again. This is what happens when you take on a really simple JIRA ticket, or whatever ticket, and put the other problem on hold. It'll remind you that, yeah, you're a pretty good developer. You can do this. Another thing that happens is that when you come back to the original problem, you have to relearn it. And this forces you to challenge your assumptions about the code that you wrote, a little bit like talking to the duck. And your brain might come up with the answer while you're thinking about other things. And there's a couple of psychological principles that are involved in this. The first is called analogical problem solving. This is when we use information from one activity to help solve a problem in another activity. What happens is that you're doing this second activity, and you start to notice that there's parallels between the two. And then you start to notice more parallels, and now you're thinking, wait, these are pretty similar things. And then you start to reframe the original problem in the context of this new activity. And it forces you to start thinking about things differently than you originally were. The other thing that's involved is called incubation. And incubation originally comes from a political scientist in the 1920s who wrote about the 4 stages of creativity. And he said, stage 1 is preparation. You investigate the problem consciously, explore it in many directions. Stage 2 is incubation. You put the problem away, and you don't work on it. Maybe you don't work on any problems. But what's happening is you now get some subconscious processing of your problem. And then illumination, stage 3, is when those 2 things, those first 2, combine, and you have an aha moment, and suddenly you realize, oh, that's what I have to do. And then verification is just your conscious analysis of the idea. You'll vet out your idea, prove that it's a good idea, and maybe expand it a little bit. Graham Wallace was very clear that these don't happen in isolation. These stages play together, and there's no real sequence to them. Our friend Mihai, who we talked about earlier, in his book about creativity, took this idea and he expanded it a little bit. The first 3 stages, he said, are the same. And then he broke that last stage into 2 pieces. Evaluation, which is vetting the idea, and then elaboration, which is exploring it. But Mihai did a really nice job of writing about what's happening with incubation. Ideas churn around below the threshold of consciousness. It's during this time that unusual connections are likely to be made. When we intend to solve a problem consciously, we process information in a linear logical fashion. But when ideas call to each other on their own, without our leading them down a straight and narrow path, unexpected combinations may come into being. Emphasis by me on unusual and unexpected. And he even goes on to compare it to parallel computing, which is right in our wheelhouse. He says when we're consciously thinking about a problem, we're pushing it in a linear direction, kind of tunnel vision. But when you put it away, your subconscious, your brain has a chance to expand it out into parallel processing. And when it's able to do that, there's more freedom in the problem solving, and there's opportunities for your brain to combine things in ways that your conscious brain would not let you do when you were in that tunnel vision. So set aside the problem. A lot of times when we're faced with a difficult problem, we think that we really need to actively focus on it, and that if we're not actively focused on a problem, that means we're procrastinating. But the truth is, if it's a really complicated problem, your brain and your creativity might need you to set it aside so that they can process it in parallel and find those interesting and unusual and unexpected connections. So go for a walk, go to the gym and work out, take a shower or a nap, read a book, get in your basement and do some woodworking, sit on your couch and knit, go mountain biking or trail running or rock climbing, and those last ones are all for me. Just let your brain expand the problem out in many directions, and it might solve it for you. The last strategy group that I have is about hardening yourself, because we know that it's going to happen again. We're going to get stuck, maybe tomorrow. And start by remembering the perspective from earlier. Getting stuck is the job. When you get stuck, you're just doing the job of an engineer. But learn new ways to solve problems. Pair with someone else, even when you're not stuck on something. It's a really good opportunity to see how they solve problems, and for them to learn how you solve problems, and maybe there's something there that you hadn't ever thought of. Read code in other projects. Go out to GitHub and just look at the code for a project that you really enjoy and see how they're solving problems there. Explore new technologies. Build a prototype in something that you think is neat and you've been wanting to play around with. And learn for the sake of learning, or learn for the sake of teaching someone else. I keep a Trello board that I call my wall of motivation. Some of you in this room are actually on my wall of motivation. But whatever measures to you as a win, you can put on a wall of motivation. I keep this up there for all the times that I've gotten messages that I really helped people, or I got really good praise about a talk or a workshop that I did. And times when I've showed great perseverance and did something that I didn't think I was capable of doing. But whatever measures as success to you, put it on a board and then go and look at it every once in a while to remind yourself that you're good at what you're doing. Another of my coworkers, Eloy, who lives on a houseboat in Amsterdam, and every time I'm on a video call with him, I can see the canal behind him. It's pretty awesome. He recommended when I first started at Artsy to keep a journal, a daily journal, of all the things that I did every day, so that I could go back at the end of the week and see that I did stuff, and see that I accomplished things. And some days you can't really check things off a box or check things off a list. But you know that you worked really hard on a problem, and maybe you made a little bit of progress on it. And keeping track of that is really helpful for you to keep yourself aware that you are doing a good job. Again, get some exercise. It can reduce anxiety and depression, and I definitely highly recommend rock climbing. I think it is the perfect sport for people who solve problems because it's just physical problems to solve. Meditate. There's mental and physical benefits to meditation. Especially for me, leveling your emotions for those times when you get stuck and you start to get angry at yourself. Meditation can help you just chill out a little bit about that. Talk about your struggles with other people. Get outside of your head. Find someone that you can share this with, that you can say, hey, I got really stuck yesterday, and I don't need you to help me solve it. I just want to talk about how stuck I felt and how I feel like I'm not doing a good job. And they'll probably say the same thing back to you. I feel that way too sometimes, because I think we all do. Maybe it's your leader. Maybe it's not. Maybe you don't feel totally safe telling them this. Just find someone that you feel like you can be vulnerable with and to tell them these kinds of things. The hardening strategies are all about conditioning yourself, getting in the reps. If you think about a professional athlete, they condition themselves for incredible physical challenges. We have to deal with incredible mental challenges every day, so we need to make sure that we're conditioning ourselves for those. Here is your cheat sheet for the things that we talked about. For starters, a mindset shift. Embrace the act of getting stuck and then getting unstuck, because that is the job. That's solving problems. Explain the problem to someone else. That'll help you challenge assumptions about what's happening. Isolate the problem to break it from a larger problem down to a smaller problem. Escape it. Set it aside. Come back to it later. Let your brain incubate. And then condition yourself, because you're going to get stuck again sometime. Thanks for your time. I really appreciate it. I hope everyone has had a great CodeMash.